Hi, this is Vasavi. Let's see how to prove few problems using trigonometric identities. So in the first question, it says cos theta times tan theta is equal to sin theta, and they ask you to prove it. So I just start from LHS, okay? The left hand side, cos theta times tan theta. So I can write this as cos theta, and the tan theta I can write in terms of sine and cos. See, actually you have to show that the left hand side is equal to your right hand side. So keep an eye on the right hand side, and you have to take the terms on your left hand side to the right hand side, right? It should match with the right hand side. So here, since I have sine, I would like to put this tan in terms of sine and cos, okay? So this I can write tan theta, I can write it in terms of sine and cos. So that is sine theta. Tan theta is sine theta over the cos theta. So what happens? The cos theta on the numerator, now I am using a bit of algebra here. So the cos theta over the numerator will get cancelled with that of the denominator, and you are left with the sine theta. Okay, so that is equal to sine theta. So which is again equals to our right hand side. Okay, so this is done. The first one is done. Now in the second question, they say show that sine x times cos x times tan x is equal to 1 minus cos square theta. So again, let's make everything in terms of sine and cos. So I start again with the left hand side. Okay, you can either start with the left hand side and go to the right, or you can start with the right hand side, solve, and you can bring it to the left. So here it is sine x times cos x. I'm not doing anything to these two, but the tan x I'm going to write in terms of sine and cos. So that's sine x divided by the cos x. So what happens here? Your cos gets cancelled with the cos at the denominator. So what is left out? You have sine x times sine x, which is sine square x. The Pythagorean identity says that your sine square x is equal to, remember, it is equal to 1 minus cos square x, right? We have arrived at the right hand side. Easy, right? Good. Next, the third one, it says cos x times cosecant x plus tan x is equal to cot x plus sin x, right? So as usual, I would start from my left hand side. So I just write the cos x. I would distribute it. Okay, I'm going to use the distribution theorem. Like I'm going to multiply the cos x with cos x as well as tan x, because the cos x is common to both the terms within the parentheses. So that would be like cos x times cosecant x plus, this plus sign is from here, okay? So this plus, now it is cos x times the tan x. Yeah, so the distribution is done. The next step is to bring everything in terms of cos. So I would bring this. Keep an eye on your right hand side. You have to bring the left hand side equal to the right hand side. So try to take it in that way. So it is cos x here, and the cosecant x, we know it is the reciprocal of sin x. So that would be 1 by sin x plus this plus sign again. Here again I would write the cos x times the tan is sin by cos, right? So that is sin x divided by the cos x. I hope you would have got the clue now. Here what happens? This portion I am just multiplying the numerators. So I get cos x over the sin x plus, here your cos x and cos x gets cancelled. So you are left with sin x. Now tell me, what is cos x over the sin x? Yeah, it is cot x, right? So your cot x plus sin x. Yeah, we have got the right hand side, right? So this is matching with what you have in the RHS, the right hand side. That's it. Proved. Hope you would have understood this. So here, prove that cos square x minus sin square x equals 1 minus 2 sin square x equals 2 cos square x minus 1. So here you need to prove two things, right? You have to prove that your cos square x minus sin square x is equal to 1 minus 2 sin square x, and it is also equal to 2 cos square x minus 1. So let's start with the left hand side. So on the left extreme you have cos square x minus sin square x. I need to show this is equal to 1 minus 2 sin square x. So I have to convert everything on my left to sin square, right? I have to, because on the right hand side I have sin square. There is no cos square. So this cos square x, I would use the identity formula, the Pythagorean identity, and I just convert it to sin square. This cos square I can convert to sin square. So you know that cos square is equal to 1 minus sin square, right? Sin square x. Did you get that? So this cos square, I write it as 1 minus sin square x, and this sign you bring down, that's a minus sign over there, and then you have the sin square x. Just leave it as it is. So what happens now? Just remove the parentheses there. So you would have 1 minus sin square x minus sin square x again. I have just removed the parentheses here. That is equal to 1 minus sin square x minus sin square x becomes minus 2 sin square x. So that is 1 minus 2 sin square x. Okay. So that is equal to your RHS. You have proved that your cos square minus sin square is equal to 1 minus 2 sin square x. Now you are going to prove the second one, where you say cos square x minus the sin square x is equal to, this time on your right it is 2 cos square x minus 1. Here we go. So just, I have always told, just keep an eye on your right side and try to take your left hand side towards the right, right? To the right. So we have cos square on our right. So this time I am going to convert the sin square into cos square. So I just leave the cos square as it is and change minus, okay? Minus, the sin square is nothing but 1 minus cos square x. So what does that mean? So this is cos square x, and when I remove the parentheses, the minus sign enters inside. So that becomes minus 1 plus cos square x. The signs change. The signs of the terms within the parentheses changes when the minus sign gets inside. Now this is equal to, so that's a cos square x plus cos square x. So that is 2 cos square x minus 1. Understood? So we started with the LHS and you have arrived at the RHS. Hence, it is proved. So the same question, we have made it in two different forms. So it should strike you like what you have to do. So for that you have to see the right hand side, and you have to take the left hand side terms in accordance with the right hand side. Okay. Now the last one, show that cosecant square x minus 1 divided by cosecant square x is equal to cos square x. Again, I start with the left hand side. The cosecant square x I can convert into the sine square. Okay. So cosecant square x is 1 over sine square x, the reciprocal identity. Minus 1 whole thing divided by, again it is in the denominator, it is cosecant square x. So I take it as 1 over sine square x. Did you get that? I've just used the reciprocal identity. So now let me take the LCM on the numerator. Since it is a fraction on this side, I just make the denominator as 1. So how do you do the addition, fraction addition? So that's a sine square theta underneath, and you would get 1 minus sine square x. I tell you what I did. To make the denominator same, I just multiply the numerator and the denominator of this side with sine square x. Now I got on the numerator it is 1 minus sine square x over the sine square x, the whole thing divided by 1 over sine square x, right? That implies, instead of writing the denominator like this, I would write 1 minus sine square x divided by the sine square x. This is the numerator, and the denominator is division, right? So I just write divided by, instead of putting the line and writing the other one underneath, I'm just writing it like this, divided by 1 over sine square. Now how do I do this? I just make the division into multiplication and flip the second part, right? So that is 1 minus sine square x divided by the sine square x. Division, I change it into multiplication and flip the second part like sine square x divided by 1. Okay. So this would get cancelled, and I have 1 minus sine square x left. So we know 1 minus sine square x is cos square x. So that is what they wanted us to prove. So we arrived at the right hand side. So LHS is equal to your RHS. Hence it is proved. So I've just taken few problems here and there, and I've tried my best to explain to you how to solve or prove them. Thank you. Take care. Bye.